where does the history of Acceleware, where did it all start and develop? I mean, radio frequency technology is obviously not a new thing, but can you talk a little bit about how Acceleware brought it into as a company and into the market?
For sure, yeah, you're right. So using radio frequency has been around for over 50 years. Typically what they used to do was use commercial or military grade units. And they're always in the past very expensive to operate, not very efficient. And the experts at Acceleware that we work with recognize the limitations of this technology. And it also been seeing other trials going on in industry. We were contacted by a US super major oil company about 5 or 6 years ago to do a postmortem on their RF pilot. And from that, we understood, we could also develop something similar that's highly efficient and at a lower frequency, lower cost.
Right. So Acceleware, where were they sort of specializing in leading up to that before that company contacted?
So we were founded in 2004, and the start of our company was mainly on software. We used GPUs as a computing platform. It was all about high-speed processing. We also then stepped into high-speed seismic. And then, as I mentioned, once we were contacted by this company in 2010, that's when we shifted into a focus on oil and gas development.
And then, so when you made that shift now, and I know you are a publicly traded company. That's correct, right?
Correct.
Yeah. So I understand that there's obviously some information that's if I'm asking something that's out of line, just let me know. But yeah. So that project, was that a funded project? Was that an R&D, a partnership? How did that develop for a company like that coming to you and wanting to develop this technology?
Yeah, no, that was, as I mentioned, a US super major. So they were, it was a public company again down in the States, and they contacted us to utilize our expertise as a consultant basis.
So that was in 2010. Now fast forward to 2017. Now, did you develop based off of that project with them? Then what was the next step that went forward? I think you ended up in 2017, you ended up doing sort of I think I got some notes here, like a 1/20th scale project. Can you sort of give that timeline?
For sure. So since 2010, significant investment in research and development, understanding current RF type practices. If you look into industry, you'll see a lot of electrical type subsurface development. They use induction, conduction. A dipole antenna is kind of your most common approach to using RF energy. And there's significant limitations to this in terms of length of your well, efficiency, cost as well. So that's where we took upon the challenge to figure out how we could do it differently.
Right. And then, so that process, so in 2000, so I want to go just through the next sort of stage. Now you've gotten 2018, there's a big focus on design, execution, planning. And then you got an agreement with, I think Broadview Energy. I'm just trying to find it here on the notes here. Can you just talk about sort of where you're at right now? And then I want to circle back and go into the technology itself.
For sure. No, this has been a really big year for us. So we announced a partnership with Broadview, as you mentioned, to do our pilot in their Marwayne area, which is just north of Lloydminster in Alberta. It's a heavy oil reservoir. Leading up to this, I was brought into the company in 2018. I have a background in the thermal development side. I've worked in quite a few SAGD operations, and I was brought in to do the project management. So what we have done is further developed the well design. As you mentioned, we did some testing in the subsurface, a 1/20th 1/20th scale test. We've more recently done a 1/4 test, you could call it. Our full scale power would be 2 megawatts. We've more recently ramped up to almost 500 kilowatts.
So Laura, I was on the website and I saw the video you have. It's quite a nice walkthrough of how the technology actually works. Are you able to we'll bring it up on the screen for the audience. Are you able to just walk us through that process?
Definitely. Well, it's a great visual. So taking a look at our well design, we have an upper and a lower well. The upper section that you're seeing are the RF heating lines. So they are two parallel lines that run up to 1,000 meters in length. And essentially these lines connect up to the surface power supply, which you see is the blue box. How these heating lines work is an underground microwave. They're heating the connate water in the subsurface. So that's the major difference for us, is that the water is in the reservoir and we're heating it using the EM energy. The production well is below those two heating lines, and it's identical well-designed configuration to a standard SAGD well. You'd have a slotted liner that connects up to surface.